you know, starting the recording of the session. Okay. So today's session, we are going to precisely talk about AI in telecom and why it is relevant. What are the things we are going to talk about? What are the different use cases we have? How do we really implement or deploy those kind of use cases? These are some kind of discussions we are going to have at any point of time. If you have any questions, please feel free to ask your questions in the chat box. At the end of the session, I will be, allow you to unmute yourself and ask your questions. But at this moment, we will just keep it in the chat box. And then, at the end, I will be talking about one course, what I'm planning to deliver starting next week. So if you're interested to talk about that, you can stay back after the session. If not, you can enjoy the learning what we deliver in first 1.5 hour, and then you can leave the session. So no obligations to listen to the course promo, etc. So people say, okay, you are promoting your course, but it's not mandatory for anyone to join that. So just enjoy the session, share your feedback, share your questions in the chat box, and I would be more than happy to answer those questions at the end of the session. Right. So with this, I'm just stopping my video. So just to say bandwidth for everyone. And let's get started with the discussion. What we are going to discuss in today's session. One second. Yeah, what we are going to discuss in today's session. So first of all, we will have a quick introduction or maybe the recap of the wireless network evolution, how the wireless network has evolved over a period of time, and the kind of complexities they bring in. And because of these complexities, AI ML becomes a critical part of the telecom network. So what are various things we can do with the AI ML? Of course, I'll not get into the details of what AI is, what ML is, what DL is. We'll try to understand these things from the perspective of telecom network. We'll also see what are the major changes has happened in the 5G network architecture when we start talking about AI ML. Right. We will also talk about some of the key AI/ML use cases in the 5G network. And we will also touch upon some fundamentals of AI/ML, DL, Gen AI, LLM, and how these things are actually changing the world of telecommunication. Right. So these are few things what we're going to discuss today. Now, before we continue and start talking about AI/ML, let us try to understand the telecom network evolution, how the telecom network has evolved over a period of time. So if you look at this journey, so 1G network and numbers are like these numbers, what you see are pretty much tentative and not the exact years, but just to give a perspective, 1G was, introduced somewhere into, give me a minute, just somebody is trying to write something. Okay, please don't do that. Right. So 1980s, we started with the 1G network. Okay, is that some, what about others? Carlos says the my volume is low. Can you quickly confirm in the chat box if it is fine with everyone? Is it so? Just allow me a second. Let me check my audio. Okay, give me a minute. Volume is okay. So it's okay with others. So maybe some people are facing some issues. Virendra, okay. Right. So, recording, yes, I will be uploading the recording on my YouTube channel. Slides will not be shared, right? So, we are not going to share the slides for this course. Okay. Right. So, we have seen every decade, every 10 years, we are coming with the new generation. So, 1980s, somewhere around 1980s, we got 1G, and 1990s, we got 2G. 3G came somewhere around 2000. 4G came somewhere around 2010, and then 5G came around 2020. Of course, there are slight, difference in the dates what I'm talking about. And we are expecting 6G network. So as per current plan, 2030 is the time when we may expect 6G network. But few things which are changing drastically in the telecom network, the data rates was increasing exponentially. So till 4G, if you look at the major change which was happening in the telecom network was giving you higher data. Starting with 5G, we started implementing so many different types of services which we refer as EMBB, URLLC, MMTC, HMTC, V2X, etc. And that's where we have started changing our focus from the traditional architectures to the architectures where we can also serve some of the industry verticals. So instead of just targeting the end users or the retail users, we are also trying to target some industry verticals where we can provide these specialized services to the industry verticals. With those kind of different services, there are a lot of new complexity comes into play, and managing those applications, those features, those functionality manually is not going to be possible. That's where the AI ML intervention in the telecommunication network is increasing day by day, right? However, this is not the first time we are using AI ML into the telecom network. It has been a historical thing, and there are many years since when we are using AI ML into telecommunication network, and we will talk about it, right? But this has taken to the next level, the kind of complexities, kind of applications, kind of features, functionality, what we are bringing into the telecom network, that makes it more lucrative for the implementation of AI ML. Now, if I look at the services, the 1G and 2G were basically designed for basic voice and SMS services. 3G and 4G were designed for video call, web applications, etc. And the 5G was designed in a way where we are trying to integrate each and everything to the 5G network. So what do we expect in 6G? Of course, as of now, these discussions are at a very early stage, but we want these 6G network to be AI native. That means from the day one, most of the applications, most of the services are going to be AI native. That means the AI is going to be an integral part of the telecommunication network or 6G network, right? So this is one thing what we are talking about, where our telecommunication network are going to be AI native. They are going to be integral part of the AI is going to be the integral part of the 6G network. So that is something what we need to understand here. So these are the service verticals, what we generally call, EMBB, providing higher data rates on the tunes of 20 Gbps as peak data rate and 100 to 200 Mbps as the user experience data rate. URLLC, what we talk about when we say, ultra reliable, very reliable network with the lower latencies, like lesser than 1 millisecond kind of latencies. And talking about MMTC or massive machine type communication, where we want to connect millions of devices. Now, in addition to this, in release 16, they also introduced V2X, and in release 17, they also introduced something called as HMTC, high performance machine type communication, which are more or less, extension of the URLLC kind of architecture. So they're basically the URLLC kind of expansions of the URLLC. We're providing some specific services related to vehicle to X communication, or maybe the industrial IoT kind of setups, right? So these are some extensions were done in the later releases of 3GPPs. When we talk about service-based architecture, these are the various network functions which include AMF, SMF, UDM, UDR, AUSF, PCF, NEF, NRF, NSSF. We have already, covered many of these things in our previous videos, and you can find those videos on our YouTube channel as well. So we'll not spend much time here. But what we are interested here is, now all these network functions are basically not the hardware boxes. They are the software applications, and they are generating lot of data, lot of insights. Now, how do we really make use of these insights? How do we really make use of this data? For that, we have brought in some new functions, network functions called as NWDAF, which we are going to discuss later, which is going to be data analytics engine of the 5G core network. Similarly, the G-Node B is also broken down into some architectures which are referred as Open RAN, which we are going to discuss later. And that is also becoming more AI focused, domain. In addition to this, there are a lot of new things which are introduced currently, talking about AI RAN, artificial intelligent RAN, and LTM, large telecom models, etc., which we are going to discuss in the upcoming discussion, right? So this is something which is 5G network architecture, where we have the base station, the core network, the control plane, and the user plane, which is not really the main focus of our discussion for today. But yes, we have already covered some of these topics in our previous sessions. Now, I'm sure if you are working on 5G, if you're talking about 5G, I'm sure most of you have already heard about network slicing. Now, how do we really allocate these? How do we really allocate these radio resources? right? Sorry, not reduce. How do we really allocate these resources and do it across the different domains, be it radio network, core network, transport network? And doing all these things will require a lot of power coming from the orchestration. So network slicing or slice resource allocation is one of the important use case for your AI/ML implementation. So how do we really capture the information from various slices and then do the resource allocation for all these slices? That is something is going to be one of the important use case for AI/ML as well. Now, we also talk about edge computing, MEC or multi-access edge computing, where we can have different type of applications situated at different locations depending on the criticality of those. So there are multiple deployment models for MEC. There are multiple models for MEC, and these multiple models are actually depending on the different use cases. And now what we can do is we can even run our MEC applications closer to the end user. That means at the G node B site, or maybe at a transmission node, maybe at a network aggregator, or more, maybe in the centralized network data center. Now, we can also run a lot of AI ML algorithms. So this is another use case where we are actually doing the AI ML implementation. The models are deployed closer to the end user to give you the real time kind of services. So basically deploying some local models closer to the end user. Of course, we can do edge computing at the devices, also federated learning as well. But in this case, we are bringing the AI ML implementation closer to the end user, where in these applications, I can have some kind of AI/ML models and they can give you value-added services specifically for some use cases, right? So these are some of the areas where we actually see a lot of potential when we talk about AI/ML in telecom. Now, orchestration is not really a new thing. And yeah, as we will see further, this network management was the starting point for AI ML into telecom network. So AI ML actually started from the telecom network management, which is typically started with the FCAPS management, as we will see in the later slides. But over the period of time, this was further extended end to end, and that architecture itself comes from the ETSI MANO architecture, where we talk about slice management or management and network orchestration. Of course, one central orchestrator cannot manage all the different domains. So what we have done here is we have divided this into multiple domains here, and all these domains have their own domain managers. They are like, domain controllers, domain orchestrator, or domain managers. They are managing their own domain. Like radio network domain manager will manage the radio network, transport network is managed by the transport network domain manager, and the core network is domain managed by the network domain manager. In addition to this, there is underlying infrastructure here. There is underlying infrastructure here, which is mostly cloud native kind of architecture, and that's where we also have Docker and Kubernetes kind of stuff, where we are using Kubernetes or K8s for the orchestration of the containerized or cloud native environments. So this network orchestration becomes another important use case. So we have already talked about these things in our previous discussions, but now what we're trying to do is we're trying to focus more on how these things are going to be useful, how these things are going to be useful for the for the implementation of AI/ML. That is what we are discussing in this particular discussion. Now, this is something which comes from ETSI MANO architecture, ETSI MANO architecture, which is the reference framework for the NFV architecture, where we have the physical infrastructure layer, which is managed by VIM, virtualized infrastructure manager. On top of that, we have various VNFs, and they are being managed by the VNF manager. On top of that, we have something called as orchestrator, which is actually managing the VIM and VNFM, which is working on the instruction of OSS BSS systems. Right. So this is the traditional architecture what we see whenever we talk about NFV framework. Also, Open RAN brings in lot of different boxes. We have like radio units, distributed units, control units or centralized units, CU, CP, CU, UP, control plane, and user plane. On top of that, we have near real-time rig, near RT rig, RAN intelligent controller, which typically takes care of the near real-time function. On top of that, we have something called as non-real-time rig, which is like your AI ML engine in the OpenAI architecture, which is that is where we actually train our models. And once those models are trained, those trained models are forwarded to the near real-time rig, which actually takes care of the real-world implementation. So models are trained here. Once the models are trained, the trained models are passed on to near real-time rig to do the deployment of those models. So this is also completely AI ML driven architecture, what we see in the OpenAI architecture as well. Now, moving on with the 6G or IMT 2030 expectations. So this is a mandatory picture whenever we talk about 6G architecture, which is the vision of IMT 2030. We see here the traditional three different verticals of 5G. They are just being extended with the three different names. So instead of EMBB, we call it as immersive communication. URLLC, hyper reliable. MMTC, massive communication. But in addition to this, they are also coming up some new areas like integrated AI and communication. So basically, making your network AI native networks. AI native networks where AI is a part of integral part of your future networks or 6G network. Not only the AI, they are also integrating sensing as well, right? So ISAC, basically sensing capabilities are also being integrated into the Telecom network. And in addition to that, we are also providing the ubiquitous connectivity as well. So these are some of the areas, some of the extension of the areas where we have three different areas, which are just the expansion of the 5G service verticals, and three new areas where we talk about integrated AI, integrated sensing, as well as ubiquitous connectivity as well. So these are some expectations what we have from 6G. The 6G has also dropped a new document just a couple of days back where they have started in release 20. They have in R20 release 20 they have already started talking about in release 20 they've already started talking about the use cases of 6G and study of those use cases. This is something which is dropped by IT 3GB maybe a couple of days back, and you can easily find that in the 3gbp.org website. Now, let us talk about overview to AI ML in 5G and beyond network. 5G and beyond network. So in this case, we are going to talk about what are the key areas of AI ML into telecom network. So what are the areas where AI ML can actually play an important role? These are related to network management and optimization. So many of the use cases related to telecom for AI ML are related to network management, optimizations, etc. In addition to that, in addition to that, service assurance and user experience. Of course, we will talk about some of these use cases pretty much in detail at a later stage. Service assurance and user experience can be another area where AI ML can play an important role. Predictive and data driven insights, where we can do a lot of data throughput prediction, resource prediction, interference prediction, or maybe usage prediction. A lot of different predictions we can do by using a lot of data driven insights, and these can be some of the new use cases. Also building some new use cases for the end user, and we will talk about it. So we are talking about how AI can be useful for the telecommunication network, and we will say some new use cases which are available for the end users, as well as we can also extend some of these use cases for enterprise as well. So a lot of new use cases for end users and for enterprise, and they are going to generate or build some new revenue streams for the mobile network operator. And that is what we are expecting from the AI/ML implementation, right? Okay, I see some people. Let me just see how to stop people to do the annotation, disable annotation for others, right? So I see a lot of people are trying to write something. Now, basically, how this all started, right? What were the early days of AI ML into telecommunication network? So without getting into too many details, initially when we talk about network management, when we talk about network management, so we defined a model called as TMN model, telecommunication management network, right? Telecommunication management network defines 5 layers. And if you are a, very old person into telecom, I'm sure you have talked about network operation center, NMS, EMS, etc. So basically, this particular layer talks about the management at the business level, services level, network management level, element level, and then finally the lowest layer is the network element layer. But in addition to that, it also defines something called as FCAPs. It was also there in the previous slide, but here we are going to talk about this into a little bit more detail, right? So basically, the FCAP stands for, okay, can you tell me what is FCAPs? I'll request everyone to tell me your understanding. What do you know about FCAPs? Anyone is aware about it? Can you just write your answers in the chat box? What is FCAP stands for? Okay, fault, 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 goals of NMS. That's correct. So that's in short. I talk about fault management, configuration management, performance management, security management, and accounting management. But out of these 5 things, our major focus is going to be on these 3 things: fault management, configuration management, and performance management. So back in 2010, when the network started growing exponentially. The network started growing exponentially. It was getting difficult. It was getting difficult to manage all these networks, in day in and day out basis, right? So that's where we thought of, bringing in some automation or some kind of machine learning into the telecom networks. And that's where we started talking about something called as SON, self-organizing network, which we are going to discuss later. So if you look at the focus area of SON, they are going to be F, C, and P: fault management, configuration management, and performance management. And their major target was towards radio access network. So most of the functionality of the SON were focused around radio access network. They were focused around radio access network. In upcoming discussion, we are going to talk these things a little bit more into detail. At a later stage, the TMN was also extended to something called a STORM, Telecom Operations Map, and ETOM, Enhanced Telecom Operations Map, which was a subset of something called as NGOSS, Next Generation OSS. We will not get into the details of this, what is TOM, what is ETOM, but this model, what you see on the slide, is actually a kind of ETOM model, what you see here. Now, as I mentioned, the major focus of SON or self-organizing network was around fault management, called as self-healing, configuration management, called as self-configuring, and the performance optimization, called as self-optimization. Now, what we can do here is, by using some of the machine learning, by doing some kind of machine learning algorithms, bringing in some automation, we can actually do MDT, minimization of drive test. We can do ANR, automatic neighbor relations, right? What we can, in the configuration part, we can do cell coverage estimation. We can actually do the configuration or parameter adjustment into the telecom network. In the performance optimization, by using these techniques, we can actually improve the quality of the network, coverage of the network, capacity, bandwidth, interface, handover. Many of these things can be improved by using these self-organizing techniques into the telecom network. But the limitation here was, this was more or less limited to the radio access network. And now we have to take it to the next level. We have to expand it to the network end to end, from all the subsets, or all the subcomponents of the telecom network are able to support AI/ML kind of capabilities. Right. Now, 5G and AI, they are actually, two different services, two different fields, but they are trying to give a lot of power to each other. Just to give an example, 5G brings in extreme capacity, multi-GBA speeds, but AI brings the contextual awareness, personalization at scale, etc. Now, what is happening here is, the advancement in AI is making 5G better, and proliferation of 5G is making AI better. Now, what is happening here? AI, okay, the AI is giving you personalization, but AI needs lot of data to give you some personalization. So 5G is feeding AI with lot of data, and AI is feeding 5G with lot of personalization. So they are actually two different type of services. They are coming together and becoming very important ingredients of the future innovation. And that's what we are trying to uh, imagine into the future network, where they work closely, they support each other. 5G feeds a lot of data to AI feeds a lot of contextual awareness to the 5G, and they will make each other better. That's what is the expectation from the 5G and AI in the future. Now, 5G network architecture, what are the different evolution, different changes we have done into the 5G network architecture with the AI ML? That is something what we are going to see in this particular section. There are a couple of questions. I will be taking up those questions at the end of the discussion. Now, as I mentioned, one key components which is introduced in 5G is NWDAF, which is the network data analytics function into the 5G network, which typically consumes the data from all the network functions, and then provide these insights to the network functions like NSSF, network slice selection function, or maybe the PCF, or maybe the policy control function. So basically, these are two network functions which are going to, and if you look at the comparison of R15 to R16 to R17, there are lot of new services which are being introduced by 3GPP in NWDF. So major changes in terms of services are happening into the NWDAF. Now, this is, we are not going to get into details. This typically talks about ORAN machine learning model lifecycle. This is actually a Linux Foundation project called as Ecumos, which is actually upstream from the ORAN software community. This is typically defines the complete machine learning model lifecycle into the open architecture, where you actually create the model, train the model, supply those model, and then you deploy these model into near art array, collect more data, put that into data lake, and then you keep on using this data for training your models in a much better way. This is typically the open RAN machine learning model lifecycle what we see here. Right. This is something what we have already discussed. So the focus of your major focus of your AI ML is going to be the network orchestration. So network orchestration, which is typically a network management, a superset of network management, is going to be one of the key focus area for your AI ML. Now, let us talk about some key AI ML use cases. Right. Now, before we talk about it, I would like to, take your attention to something called as AI RAN Alliance. AI RAN Alliance is one of the latest introduction into the telecom network. So they have built a new alliance called as AI RAN Alliance, and they typically talk about AI for RAN, AI on RAN, and AI and RAN. However, what I have tried to do here is I have tried to extend this definition not to RAN but to the telecom. So whenever you are trying to do something related to AI in telecom, what we need to do here is what exactly we are trying to do with AI into telecom. So there are three things here: AI for telecom, AI on telecom, and AI and telecom. That's exactly we are going to discuss here. Now, what is AI for telecom? The AI for telecom means leveraging the capability of AI ML to optimize telecom network, and enhance some of the existing applications of the telecom network, be it resource allocation, be it performance management, QoE management, slice resource allocation, network traffic prediction, anomaly detection. These can be any number of different use cases, and number of different use cases which can be enhanced, can be implemented in much better way by using AI for telecom. AI on telecom talks about building new AI driven applications. Building new AI driven applications. And these AI driven applications are going to give additional services to the retail and the enterprise customer. And they are going to generate some new revenue streams for the operator. So basically, building some new revenue streams for the operator by bringing in new AI driven application. Now, the biggest problem or challenge what we have seen with the telecom network is telecom network are infra heavy network. That means to build a telecom network, you will need lot of infrastructure. And that same problem also aligns with the AI. AI also requires. So nowadays we see a lot of discussion happening around CPU, GPU, the kind of fight between Chat GPT and OpenAI and DeepSeek, where somebody's spending $100 million, somebody's spending $5 million, right? So it's all happening around the infrastructure. But now if you see, if we try to build the different infra for telecom, different infra for AI, that is not going to be a great solution for the future. So what we need to do is we need to build a converged infrastructure. We need to build a converged infrastructure which can be used for telecom as well as AI or Gen AI workloads. So the same infrastructure what we are trying to use can be used for telecom, can be used for AI workloads as well. So basically, just to take an example, it may not be great example at this stage. We see that, let's say, we have a capacity of 100% into the telecom infrastructure, but this capacity varies throughout the day. So whenever you see, especially in the night time, when you see that your usage are at 10 or 20%, right, the usage of your infrastructure are at maybe 5 to 10% or 10 to 20%, the remaining capabilities can be used to train your AI ML model, can be used to, host your AI ML workloads as well. These are the capabilities which are going to help you to use underlying infrastructure both for telecom and AI, Gen AI workloads. Now, what can be the various use cases? So this is just a list. This can be even more extensible. So we have basically talked about machine learning types. What are the different machine learning types? Supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, self-supervised learning. Generally, you will see these three things, the one, two, and three. But then there are some subsets where we talk about online learning, federated learning, self-supervised learning, semi-supervised learning, etc. And these are some specific use cases for all these, and even these learning, these machine learning types also have some subtypes, which we are not going to discuss in this session, but yes, we will be covering that in our course. But here we can talk about network traffic classification. We have some kind of classification, some kind of regression subtypes. In unsupervised, we have anomaly detection, segmentation, k-means clustering, etc. Basically clustering we use. In reinforcement learning, we can have use cases like SON, what we discussed, dynamic spectrum allocation. In semi-supervised, we can have fraud detection, coverage optimization, etc. For self-supervised learning, we can talk about 5G network health monitoring, traffic pattern prediction. And there are some use cases they can be built with multiple different type of machine learning types, and they can be future they can be extended to DNN as well. DNN are called as deep neural network. So basically, this is, we normally refer this as AI, ML, and DL. AI, ML, DL, artificial intelligence, machine learning, and deep learning, right? So we can actually implement some of those use cases with machine learning. Some of these use cases can even be built or implemented with the DNN as well, or deep neural network as well, right? Recently, there was one white paper which is introduced named as LTM. LTM, I'm sure most of you have heard about LLMs, large language models. So the large language models are basically the building blocks of any generative AI platform. Any generative AI platform, we have Llama 3, this OpenAI, Google, Apple, they have a lot of different LLMs available, Cloudy from Anthropic. There are a lot of them. But what we need to do here is, if we really want to do something special to telecom, we need to train them on domain specific data, right? So if you want to build a very beautiful telecom specific application, you need to train them on telecom specific data, then only it will work. So basically, these LTMs are going to be trained on telecom specific training data, advanced capability and use cases. They are all going to integrate with the telecom ecosystem, natural language processing for telecom, and also building some applications around generative AI for telecom. That's what we are expecting from LTM. Of course, these discussions are at early stage. There are a lot of companies working on this. Every day they are dropping one or the other bomb into the generative AI industry, and there is a lot of fear, how this AI is going to, go to impact the jobs in the future, right? So they say, AI can do coding, they can create designs, they can do n number of things. Of course, it is taking a lot of impact into the industry, but how it will unfold in the future, that will be, a little interesting to see in the future as well, right? Now, just to take a few names here, what are the different use cases we can have? What are the different use cases we can have? We can have use cases related to network planning, where we can actually design our cell sites based on the available data what we have. We can define. Earlier, we used to do RF planning, RF surveys to design the cell sites. Dynamic resource allocation, dynamic spectrum allocation, network intelligence for improved cell coverage, traffic prediction, intelligent slicing, intelligent power control. These are some of the use cases related to network planning. Similarly, we have use cases related to network optimization. How do we really actually adapt the network to the real time conditions? So managing the interferences, self healing the network. That's more related to the fault management, etc. Right? And also, migrating real services on the real time basis. These can be some of the use cases for the network optimization. Network O&M is another interesting area. Network O&M is another interesting area for AI/ML, where we keep on monitoring the network APIs, automated ticketing system, predictive maintenance, where we actually predict the failures of the devices and do some kind of steps to avoid that. Root cause analysis, RCA, is one of the key area of the telecom network, where we have to find the root cause of any problem. Network intrusion detection, alarm correlation, predictive hardware maintenance, etc. So these are some of the areas where AI/ML can be a great help, right? QA improvement, quality of experience, basically giving better quality of experience to the user, where AI-based congestion detection and dynamic traffic rerouting can help you to manage the QoE for a particular user. And then we can also build a lot of end user applications which can be related to AR, VR, smart device management, autonomous factories, smart cities, fleet management, autonomous cars, and number of different applications can be created which are specifically targeted towards the telecom infrastructure. And then there are a lot of different end user applications related to agriculture, transport, fleet management, connected city home, remote operation, especially in the mining kind of environment, smart logistics, factory automation, right? And a number of different applications which can be built together with the power of AI and ML, right? Now, how do we really implement machine learning and deep learning in telecom? I'll just allow me a second and then we'll continue with the discussion. Okay, so in this particular discussion, we are going to talk about how this machine learning or deep learning thing will work into the telecom network. Please note, this is not specific to telecom. Of course, we are taking more examples related to telecom, but it can be used across different industries. But here we are talking about the telecom specific use cases, right? Now, when we talk about it, first step, so first of all, let us try to understand why do we really need machine learning and deep learning into the telecom network. Please note, I have not really talked or spoke about what is AI, what is ML, what is DL, because we had limited time and we wanted to best utilize our time. So these are some basic fundamentals. Of course, we are going to cover that in our course, but here we are not talking about it. So the 4G and 5G networks are generating massive amount of data. Now, this data, and when we have these things in abundance, they also create a lot of problem. Managing the behavior of the user, behavior of the slices, behavior of the network components becomes very crucial. And managing all these things in an effective manner, the MLDL will come for your rescue. That's where they are going to help you. As we discussed, future network or 6G networks are going to be AI native network. So almost each and everything will be impacted by AI. Need for intelligent automation. Of course, most of the management, most of the things related to network optimization, network design, planning, etc., can be done with the automation as well. They are also going to enhance the customer experience, which will actually reduce the customer churn and bringing in some new innovation in 5G, 6G, which are similar to SON, what we have discussed earlier. So these are some of the, not limited to this, but these are some of the reason why do we really need machine learning, deep learning in telecom. But one important thing we need to understand here is it is not really new to the telecom. We are having not happening, we are having these things into the telecom world from many, many years. Maybe I would say, maybe another last 15 years, we have been using some of these things into the telecom world. Right. Now, first of all, the first step to get started with it, to define the use case, what you want to build. Right. And I will be showing you some demonstration, how, what are the different use cases, how they can be built, and what are the different things we do into these particular discussions. Right. So basically, the use case can be related to customer churn prediction, can be related to network anomaly detection, fraud detection, traffic forecasting, QoS optimization, call drop prediction, 5G network slicing optimization. So you can choose, okay, I have to focus say on network anomaly detection, for example, or I want to do some kind of resource network slice optimization, etc. Right. So you can decide what type of use cases you want to get started with. Now, first of, once you have decided with the use case, you need to collect the relevant data. You need to collect the relevant data. This data, depending on your use case, can be some CDRs, call detail records, can be some kind of PCAP logs for your network, can be some CSV files of network KPI and counters, billings and CRM system if it is related to BSS system. If it is related to some smart connectivity, IoT device data can be useful, or some information coming from the OSS, BSS system. What are the key steps to, collect this data and understand this data? Where we need to see, hey, what are the different data schemas we have got? We can have structured data, we can have unstructured data, we can have multi-model data, we can have, the data which is, having multiple different types of data schemas as well. So we need to understand the data schema, and based on that, we need to understand the models what we are going to use. We should also need to see what are the key attributes relevant to the problem. So basically, whenever we design these things, first of all, we need to see the input. Not always, but generally speaking, we need to see what are the features, one, two, three features which are going to be the input to the model. So when we talk about supervised learning, for example, and then it has a certain output. This output may be labeled, maybe, unlabeled, or maybe has to be, understood automatically by looking at the patterns of the data. There are multiple different ways of doing these things. So basically, we need to understand what are the key attributes or key features which are related to this particular problem. We also need to see how these key attributes are interrelated, how they are actually, impacting each other. So basically, we need to see the correlation between the different inputs. So maybe whenever one increases, two decreases, or three increases, two increases. So there can be some correlation between these inputs as well, these features as well. So we should also need to see what are going to be the correlation between the different features. Once you're done with this, we need to do some kind of data pre-processing or data wrangling. Data wrangling is often 70% of the work, where we have to handle any missing values and outliers. Of course, we are not going to spend much time here talking about all these things. So basically, we have to handle if there is a data which has lot of missing values, how do we really handle it? Either we are going to drop those columns, or we are going to replace them with mean, mode, median kind of stuff. Or if there are some data points which are very different than most of the data, how do we really manage it? When we have some different values, how do we normalize or standardize? So we use normalization techniques. We use scaling techniques. Just to take an example, if I take an example of, let's say, in network traffic prediction, where I can see the delay and throughput or data rate. When I look at the delay, it ranges between 1 to 10 millisecond. But when I talk about data throughput, it can range from 100 or maybe 100 GB to 20 GB. Now, if you look at it, when the machine learning model looks at it, it sees values between 1 to 10 millisecond and sees values from 10 million or 100 million to 200 million kind of numbers. It actually creates the confusion for the model. So what we need to do is, okay, delay is a different parameter, data rate is a different parameter. So just to avoid any confusion, we try to bring those all numbers into a similar range, not the same, but similar range. That's how we normalize the data. So we do some kind of scaling of the data. So data pre-processing is very important part of your AI ML implementation into the telecom. If you don't do it properly, then all other things will be screwed up. We also need to encode the categorical values. Machine learning models, they just understand numerical values. But let's take an example where we have one of the network slice as EMBB, another network slice as URLs, another network slice as MMTC, right? The model doesn't understand this. So we have to convert those categorical values into some kind of numerical values. We also need to create some time-based features, for example, RRC procedure. And for logs or some kind of PCAP data, we also need to create some kind of sessionization. How do we really define those parameters as per some sessions? What are the tools we use? We use tools like Pandas, Panel Data, Numerical Python, Scikit-learn, Spark, right? So these are some of the tools we use for data pre-processing. Now, after this, we have to do the EDA, exploratory data analysis. We need to see the correlation, distribution, anomalies in the data. We also need to see time series behavior, how these data are going to uh, behave when you are going to have some kind of continuous values. And class imbalance, for example, fraud thing should be a rarest of rare values, right? So there are 99.99% they fit into one class, but one particular thing fits out of that. That is typically a class imbalance. So how do we really manage all these things? To do this, we use various visualization tools, which can be Matplotlib, Seaborn, Plotly, etc., which can give you a variety of different graphs, which you can use for your data exploration. Once you're done with this, you have to choose the right models. Okay, some of the things can be satisfied by machine learning. Some of these things may need much more details in terms of deep learning as well. So if you want to do, classification, you churn prediction or fraud detection, or maybe in logistic regression, You can use random forest, XGBoost, etc., regression, network API forecasting. So there are different and number of different techniques what you can use for machine learning. For image, like any computer vision related thing, to check network heat map, etc., you can use convolution neural network. If you have to build some kind of time series data, you can use RNNs, recurrent neural network, or maybe the long short-term memory, which is an enhanced version of LSTM, or maybe GRU, gated recurrent unit, right? And then we use autoencoders to do that anomaly detection in network data, transformers or natural language processing, log and ticket classification, chatbots, etc. There, that's where the Gen AI and generative AI comes into play, right? Once we are done with this, you are going to do the model training and evaluation. Model training and evaluation, right? Where we are going to split our data into train, test, and validation. How much amount of data we are going to use to train our model, how much data we are going to use to test or validate our models. We use various metrics like accuracy, F1 score, MSC, MAE, ROC, AUC. Depending on the task, we use different type of metrics. And then we also do something called as hyperparameter tuning. And we also do some kind of cross, validation as well. So for this, we use tools like scikit-learn, TensorFlow, Keras, PyTorch, Optuna, etc. for tuning, right? So these are the various things we do for model training and evaluation. Model explainability, okay, what you are doing, why you're doing, how you're doing. So basically, you have to explain that to telecom regulators or the stakeholders. So you need to, explain the decision why the churn was predicted based on certain behavior. So you also need to understand how this model is working and why this model is predicting something. So maybe you need to explain that to your customer, to your stakeholders, or maybe the telecom regulators. So based on that, you have to give them the explanation. Once you are fine with the model, once you are able to satisfy your regulator or your stakeholder that this model is working well, you can go ahead and deploy these models. You can go ahead and deploy these models. These models can be deployed into OSS BSS pipeline. They can also create some kind of batch inference for the reports and the dashboards which are being generated. And you can even deploy it on some kind of edge deployment for some specific 5G use cases as well. And you use techniques like Flask, Fast API, Docker, ONNX, Kubernetes, ML flow, etc. to deploy these particular models. Finally, once your model is deployed, you keep on doing the monitoring and keep on taking the feedback. So basically, you actually monitor the models, reschedule the retraining with new data. So when you deploy the model, it will generate new data. You have to take inputs from this data and keep on retraining your models to make it better, and also track the performance matrices over the period of time. So this is the step 9 of monitoring and feedback. And of course, use these feedback loops to fine tune your models, leverage federated learning for privacy preserving. So if you have, let's say, you have privacy preserving problems, so where you don't want to share your data from one site to another site, or maybe mobile phone don't want to share their data with the network. So you can also run a piece of your learning or machine learning on the device itself, which will take some output and then give this particular output to the global AI models. So federated learning can be used when you have the data where you have to preserve the privacy. And we also need to prepare for future generation use cases like self-learning network, intelligent edge computing, etc. These can be some of the innovation which can be done into the future network. Now, to do all these things, we have to use lot of different techniques. For machine learning, we use scikit-learn, XGBoost, LightGBM, etc. For deep learning, we use TensorFlow, Keras, PyTorch. For big data, Apache Spark, Kafka. Monitoring, ML flow, Prometheus, Grafana, all these different tools and techniques what we use for our, you know, implementing these ML and DL models, right? Now, before we, continue further, I'll just take you through some kind of different models, what we can have here. Give me a minute. Here it is. So I'll just keep it here, open Kaggle. So I'm using a tool called Kaggle where we have already built a lot of use cases, for example. So we have built the use cases related to SON handover optimization, telecom chatbots, LSTM for seed analysis, anomaly detection using encoders, and SON using reinforcement learning, AI-driven network slicing, AI for energy efficiency, supervised learning, fault detection, and predictive maintenance. So we normally build all these models and build all these use cases during our courses. So just to take an example, let me take an example here with the zone. 1 second. Okay, not the another one. It doesn't show any this thing. Anomaly detection. This is another model what we have built here by using autoencoders. So you see this? It shows some kind of anomalies. The things what you see here, these red dots are basically the anomalies in the data, right? So this is how in this one, if you go here, you will see that we are using PLT. PLT is matplotlib. You will see that using import matplotlib and use that as PLT. So we are using pandas here. We are using NumPy, matplotlib, Seaborn, and some models from scikit-learn, some models from Keras. So all these things we discuss in our courses pretty much in detail. So we have built a lot of use cases. So in our course, we actually share all those data sets, actually build all these models into the hands-on exercise as well. Right.